Welcome to another math problem of the week. Two players game and they play optimally. Let's talk about it. In a two-player games, each player takes turns to give an integer. It's either 1, 3 or 4. And note that 2 is not allowed. The sum of this number is then limited to 100. The winner is whoever reached the sum precisely equals to 100. Now, what number must be the first player say to ensure that he or she will win the game if both players play optimally? Obviously, the answer can be only A1, B3, C4, or D. No matter what, the first player always loses. What do you think?
Pause the video now if you wish to solve it. Keep watching the video once ready.
The usual technique to solve this problem is to get a smaller number. So for this question, the sum is limited to 100, and whoever reached the sum precisely equal 100, they wins. So we can change this number 100 to n. And we will consider what happened for smaller n, and hopefully we can see a pattern. So we will say that there are two players, and the first player is x, and the second player is y. So we will form a small table where n starts from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the next column, I will either put x or y. If I put x, meaning that player 1 will always win if both of them play optimally. So if this n is 1, then x can just say out 1 and he or she win. However, if n equals to 2, he or she can't say 2. So it must say 1, and the second player y will then say 1 and the sum up equals to 2. So in this case, y will win. And obviously, if n equals to 3 or 4, then x will win in the first turn. Now, how about 5? When n equals to 5, the first player shouldn't say 1. Otherwise, the second player choose 4, then x lose. Similarly, the first player also cannot say 4. Otherwise, the second player will say 1 and the second player wins. So he choose 3. When he choose 3, the remaining of 2. Then this case is just that y become the first player and n equals to 2. And we know that at that case, the so-called second player will win. And therefore, x is the winner when n equals to 5. When n equals to 6, similarly, we want to give a remaining sum of 2 to the second player. So the first player should choose 4. So again, the first player wins. When n equals to 7, whether x choose 1, 3, or 4, the second player will always win. Example, n equals to 7, first player choose 1, then second player should choose 4. Then now first player will have the sum of 2. Then the first player will lose. Okay? Because he can only choose 1 and followed by the second player 1. If he choose 3, then obviously second player can choose 4 and second player wins. Likewise, if he choose 4, then the second player choose 3. So in this case, the second player always wins. And now we shall look at a better way to get the answer by not listing all the possible cases. So when n equals to 8, the first player can choose either 1, 3, or 4. He can let the second player to have the remaining sum of 7, or 5, or 4, depending on whether he or she choose 1, 3, or 4 respectively. When n equals to 8, the first player will win by saying 1, and let the remaining sum of 7. Using this example, it suggests that it will be easier if we use number instead of x and y. I change to 1 if the first player wins, and I change to 0 if the first player loses. So the corresponding value will be as shown, and call this is Fn. And using the example that we illustrated just now, we will see that Fn will be highly corresponding to Fn minus 1, Fn minus 3, and Fn minus 4. So it is, so let's say for example, this value equals 1 if any of this value is equals to 0. If any of this value equals to 0. So we can have a reconciliation that Fn equals 1 minus Fn minus 1, Fn minus 3, F4. And now we can actually fill in the numbers here a lot more easier. And we'll look at what happened to when n equals to 9. And it suggests that it will be 0 as n minus 1, n minus 3, and n minus 4, sorry. n minus 4 are all equals to 1. And for this one, the n minus 1 equals to 0, and therefore it must be equals to 1. And for this, it's 1, 1, and 0, so it is equals to 1. For this, it is 1, 0, so it is equals to 1. For this, it is 1, 1, 0, so it is 1. And for this, it is 1, 1, and 1, so this is equals to 0. And the pattern will follow. Okay, now let's look at the pattern that we can see here. It is 1, 0, 1, 1, 1, 1, 0. And after 7, it will be 1, 0, 1, 1, 1, 1, 0. And the pattern will follow because of this relation. It always repeats the pattern after 7 terms. Now we are ready to solve this. Okay, let me erase this. So now we know that Fn will be equal to 0 if it is 2 or 0 mod 7. And Fn will equal to 1 if otherwise. And we know that 100 is congruent to 2 mod 7. And this means that when n equals to 100, the value will be equal to 0. And the value is equals to 0, it means that the second player will win, which means that the first player always loses. And therefore, the answer for this question is D. If you enjoyed this video, please like, comment, and subscribe. So for now, let's look at other people's solution. That's all for today's lesson. I'll see you again next Tuesday. Bye bye.